afternoon, everyone. I am Chiara Loprete, very glad to introduce Emily Grubert today. So Emily is Associate Professor of Sustainable Energy Policy at the University of Notre Dame, at the School of Global Affairs at the University of Notre Dame. She's a civil engineer and environmental sociologist who studies how we can make better decisions about large infrastructure systems, particularly related to justice centering decarbonization of the US energy system. So she's going to tell us a little bit more about what her research is about, but her major methods include scenario analysis, life cycle assessment, survey and interview research, and text mining. The title of her talk today is Public Support for Energy and Climate Technology Deployment. And with that, Emily, I'll just leave it to you. Again, thank you so much for joining us. And I really look forward to inviting you the next time in person, okay? So we can meet in person. Thank you.
Thank you so much. Yeah, thank you for having me and managing around schedules. It's really a pleasure to be here, and I appreciate those of you that are spending a little bit of time with me today. I think one of the great advantages of a fairly small group is hopefully we can have a little bit of a conversation. So, we're 5 years past when we first started teaching online. I'm reasonably good at watching the chat as I talk. So if people want to raise hands or put stuff in the chat, I'd love feedback because this is some work that's actually relatively it's not necessarily new for what I've been doing, but it's kind of new to put this all together. So I really look forward to any comments that people have. But without further ado, I will just share my slides. What I really want to talk a little bit about is kind of new models for thinking about public support for energy and climate technology deployment, and really in the context of governance-related kinds of demonstration projects and things like this. So I'll talk a little bit about why I'm coming at it from this angle, and then maybe get into a couple of examples that I hope are kind of interesting. The other kind of background to this is that I did spend some time at the Department of Energy working with the Office of Fossil Energy and Carbon Management on some of the big infrastructure deployment things under the bipartisan infrastructure law and that era, and really talking quite a bit about how some of the technologies that particularly around some of the hydrogen and carbon capture things that had some potential challenges with the way that they might be deployed in terms of actually delivering justice and really delivering climate action. Watching that process go forth, I think really informed a lot of the way that I think about the role of the public here and the role of the government in particular. So to maybe drop the punchline at the very beginning of this, I am going to be talking a little bit about something that ultimately I think would lead to basically a pretty centralized control of a lot of the transition, and probably in the form of some nationalization types of activities just as a governance model. So that's a little spicy maybe, but I want to explain why I think that that's something that we really should think about from a going forward perspective, and why that looks like changing the way that we think about public support. Okay, so I think this is probably not unfamiliar to people, but one of the things that I think is so important when we think about what it actually means to transition is that if the target is this sort of normative goal of reaching, I'm saying net in parentheses, but net zero greenhouse gas emissions. So zero greenhouse gas emissions, and then potentially adding some carbon dioxide removal into there to reach net zero if we can't actually completely eliminate greenhouse gas emissions. Reaching that goal, which is not necessarily something that comes from an absolute objective perspective, but this is sort of a normative goal that gives us an endpoint. Doing that requires either closing or dramatically remaking about 80% of the world's energy system. And I think the reason that I start with this is just to emphasize this isn't a little bit of technology demonstration around the edges. This isn't just a little bit of deployment to kind of catch up to where we've been before, ramping up a few percent relative to what we've been doing. This is a really, really dramatic remaking of basically one of the most fundamental and life-critical infrastructure systems that we have. This takes a few forms. I think the ones that matter the most when we think about justice in particular, and when we think about climate success, are power, kind of being the most typical one. In the US, this is the system that's probably the the furthest advanced when we think about transitioning. So, kind of 60% fossil based on the electricity system at this point. What this map is showing is basically all of the fossil based generators that were operating as of the end of 2018. The map doesn't look that different if you update it to the more recent ones. But what this is basically showing is a map of all of the power plants you would need to shut down. In this case, red is gas, the blacks and browns are coal plants, the couple of little green dots are the sort of rare oil driven power plants in the United States. And then the counties are colored according to how much labor we see associated with keeping these plants online. The overall project behind this, and this website in particular is interactive through time, is basically just to show that a lot of these plants are reaching end of life. And so there's a real opportunity to step in and ensure that those transition to something not fossil based relatively near term. But the point, I think, of having this slide here is just to emphasize this is a map of things that we need to close. It's pretty dense. It's pretty well distributed through population centers in the United States. And there's a lot of kind of interesting characteristics of where things are. So if you look at this map closely, you can see a couple of the really big natural gas pipelines that go through the east. You can see a lot of rivers with a lot of coal plants being cooled on them. But I think what's really useful about thinking about existing fossil infrastructure when we think about this normative goal of closure is that we actually know where this stuff is. We know how big it is. We know how many people work there. We know a lot of the characteristics of these sites. This is not really a theoretical thing. We know where these plants are. But nonetheless, there's a lot to close down. And this, I think, kind of informs why we need a new system of governance, not letting these things just kind of close because they choose to or because they run out of profitability, but really thinking very carefully about when and where things close, in what order, and what they're being replaced with, because otherwise we do lose a pretty critical service. I think similarly, when we think about transportation, most transportation fuels are oil based. So we're still in the sort of high 90s% of how much of the transportation sector is based on petroleum, even with the advent of electric vehicles and so on. But when you think about cars, planes, boats, all of these types of things, we're very, very oil dependent. And so thinking about this transition, there's a huge amount of capital and a huge amount of individual machines, basically, like in the form of cars largely, that would need to be transitioned over. So again, kind of pointing to this notion that allowing this to happen voluntarily is probably not going to be particularly effective if the goal is zero, but also to ensure that people still have access to their jobs and other things that they need to be able to get to. It's really something where we do need a little bit of a more directed model for how we actually think about transitioning. The last one I think is probably also familiar to all of you at Penn State. This is maybe a little bit more surprising to people when I talk about this in warmer weather climates, but transitioning the heating system is the other really, really significant sort of fossil to non-fossil transition that we anticipate in the United States. I think the point of bringing this map along is just to point out that all these reds and purples are where we have really directly fossil dependent heating systems in people's homes, businesses, things like this. And as is probably predictable, where we do see direct combustion being used for heating tends to be in the coldest places, just because it's very difficult to do this with electricity. It's difficult to build a grid that's actually able to keep up with winter peaking and so on. But the point of bringing these kind of power, transportation, and heating system images here is just to say, when we think about actually getting to these normative goals that we have for stopping ongoing contributions to climate change, it's not just about technology deployment. It's actually about kind of a wholesale remaking of these really significant infrastructures very, very quickly. And so this is kind of the rationale that I'm presenting here for really thinking about governance quite differently and what public support looks like in an era where you need to be turning over entire infrastructures is pretty different from what public support looks like when you're talking about trying to trial a new technology. So we kind of know heat pumps work. There's some stuff to be handled around the edges. We kind of know wind works, solar works, these types of things. What we don't know is how to actually transition all of these systems over in a rapid way that ensures continuity of services and actually ensures that that transition is going forward. So that element of moving beyond technology deployment and moving toward entirely new systems of governance and sort of demonstrating whether those work, I think is a lot of what I've been thinking about lately. So to kind of put another frame on this a little bit, something that I've been talking about a lot for the last couple of years is this concept of a mid-transition, where essentially there is a period where you have both carbon-based and zero carbon systems in the energy system that have to be operating together, while one of them, the carbon-based one, is declining, and while the other, the zero carbon system, is growing. So you have this period of extreme technological dynamism that again underpins a lot of life safety critical services that we actually need to keep operating even before this transition is actually finished. And I think the point here is that this basically requires coordination. Having some system where the carbon-based things are essentially just closing as they reach the end of their lives or as they reach the end of their profitability, and zero carbon systems are coming online sort of as people decide to move forward or seek a subsidy or something like that, can get us a decent part of the way. And that's kind of what we've seen in the US so far. But it's not something that gets us to zero because it's so challenging to actually have these systems running together. So I think the other point here is that this mid-transition period is much more chaotic than the endpoints. So when you have a system that's mostly fossil-based, you kind of know what that looks like and you can design around it. Our governance systems are designed around that. So even the way we talk about power plant efficiency and things like this kind of presumes a thermal system. The end state, where you have a mostly non-fossil based system, similarly can be evaluated on the metrics that are most appropriate for those systems. But that middle period where you have both systems and it's not stable is actually much more chaotic, much more expensive, and much more challenging. So this notion that we actually do need more coordination is really predicated on the idea that we have this period that's very chaotic and potentially pretty dangerous. The challenge of this too is that we're starting to see some of these things happening, and this is a very US perspective, but a lot of the same conditions apply in the rest of the world with slightly different flavors. But at least here, this hasn't really started yet. So to give a little bit more of a definition here, what I'm talking about with this mid-transition period is basically the time when each system, so the fossil system and the non-fossil system, is too small to support all of the energy services that it needs to provide, but too large to operate without affecting the other one. So what we see here is maladaptations as one system is having to kind of constrain itself in order to allow the other to operate. So things like seeing natural gas fired power plants have to ramp up and down a lot more as we have more solar and wind coming onto the grid. And on the flip side, seeing solar get curtailed in the middle of the day because you actually have to accommodate some of the big always on thermal plants, like some of the coal and nuclear facilities that we have in the United States. So minor examples, but things we're actually already starting to see. One of the things that I think is important about this from an engineering perspective and from kind of a public demonstrations perspective potentially is that a lot of these kinds of maladaptations are fairly predictable. We don't necessarily know when exactly they're going to happen or the extent to which they're going to happen, but if you really sit down and think a little bit about it, you can predict a lot of these types of outcomes. One of the ones that we're seeing a little bit in a couple of particular markets, but I think is likely to become a lot more important over the next few years, for example, is just this point that American refineries are very much tuned toward producing gasoline. The other products they produce from crude oil are sort of tuned around the traditional demand mix that they face. So when you see drop for petroleum fuels actually happening in a nonlinear way across the different kinds of fuels that they're providing, you end up putting these refineries into pretty challenging situations. So, for example, if you have a lot of cars that would have been using gasoline switch over to becoming electric vehicles, but you don't have a kind of similar drop in demand for jet fuel or something like that, the refinery is actually going to have a pretty hard time managing that. So we've seen some closures out in California. We've seen some real challenges with this in Hawaii during COVID in particular. But those kinds of things are predictable. Similarly, you can think about a system where natural gas pipelines aren't able to maintain pressure throughout the whole system when you see big drops, maybe from power versus heating or something along those lines. But the point is, this is stuff that we can see coming and can therefore kind of plan around and think about, but only if we actually acknowledge that this is something to be happening. So that's probably a role for public demonstrations and public support as well. The other piece here is that in the mid-transition, you're essentially forced to operate duplicative systems, one that's declining and one that's growing. But this means that there's a lot of things that aren't really marginal costs associated with those systems that you have to keep going at the same time. So you need workforces that can operate both. You need regulatory infrastructure, all those kinds of things. That's expensive, and it probably means kind of an overinvestment in the energy system during this period of transition while the new system is essentially growing into its ability ability to actually provide everything. But I think a lot of energy systems models sort of suggest that this could be a fairly linear process. And maybe the point that I'll try to make in a few slides is that that's not really true. You probably do need to keep a lot more of the fossil system around until the very end than you think. So it's not really the case that you can keep a couple of natural gas plants here and there, because you also then need to maintain maybe 200,000 miles of transmission pipelines that are able to operate under really extreme conditions. Like those kinds of things that mean that actually you probably are going to have to be double paying, double investing, double employing for quite a while. I think the other thing about the mid transition that's a little complicated is that it's not that you have a pre transition, post transition, and transition state. This middle period is completely dynamic because you've got one system declining pretty quickly with a lot of probably nonlinearity associated with it, and another one growing similarly in a nonlinear fashion. So once it's not really the case that you can find a new stable point for a while. Simultaneously, we see climate change advancing and really affecting a lot of our operational envelopes for all of these systems. And so this is a really challenging thing that probably demands quite a lot of investment and probably can't be left to complete profitability market kinds of structures, because if the system fails, you lose a lot of very critical services. So kind of having to acknowledge this is not going to be a super efficient process, I think, is another place that I'm coming from here. So minimizing time in this transition period is desirable. I think sometimes when I talk about this, people are like, okay, so yes, this is justification that we need to keep the fossil system along for a while. And I think the point that I'm making is actually we would like to push through this period as fast as we possibly can, because we would like to reach that more stable outcome at the other side as quickly as possible so that we're not having to deal with all of these challenges in the middle. And then the last point that I'll make here is just that as we think about coordination and why this is such an important thing potentially as we start to think about public support and demonstration, is that different energy systems are likely to enter and exit this transition period at different points. So the image here is showing the penetration of kind of modern renewables, variable renewables, so mostly wind and solar, on a state level for the electricity grid, and kind of showing that if you assume that the sort of big chunk of the middle part of the transition is kind of between 20 and 80% penetration, very few states have actually reached that point yet, but also they are happening at pretty different rates. So looking at parts of the wind corridor in particular, you see quite a bit more penetration of wind, especially. And then some of the more climate-oriented policy regimes, especially out west, where there's quite a bit of solar support and things like this, you see a much higher penetration. But it's not like the whole country is at the same place on this transition, and electricity is probably significantly more advanced than the other things that we're seeing move. So this is not really a thing where you have one process that you kind of do as fast as possible. It's a whole bunch of different processes that are really dynamic, really challenging. If you mess up, you could kill people, and it's something that you actually really need to manage, probably with pretty significant resourcing. So unplanned transition is a safety problem. I think this is one of the other real points for why public support of the transition is so important. You do kind of need something around to make sure that all of these systems are actually being supported. So this is an image that some of you might be familiar with, basically from the big freeze a few years ago in Texas. Where essentially expectations that the natural gas system was going to be available under these emergency cold weather conditions meant that there wasn't a whole lot of other planning for what might happen if that wasn't the case. There was kind of a general assumption that those plants would be available. And then when they weren't, the whole grid almost went down. Kind of interestingly, probably the very small amount of sort of rapid response hydropower that exists on the ERCOT grid probably prevented some pretty significantly larger problems here. But this was a very, very significant event that could have been significantly worse. But basically, I think it's an important illustration that when you don't have real clarity about which systems are providing which kinds of services at which times and under which emergency conditions, you can get into some very scary places. So considering that something like this might become a lot more common as you start to see less backup capacity, as you see some of those systems being less well maintained, people not necessarily having quite as much experience operating these systems, both because we're seeing a lot of labor exiting and because we're not really training a lot of new people in a lot of these areas. There are a lot of challenges associated with this that really point to the notion that we need some planning around how this works in order to preserve public safety. In a very similar vein, when you talk about abandonment of a lot of the fossil infrastructures that we see historically, a lot of the time the costs associated with that abandonment ends up pretty socialized. So this is a lot of images from Appalachia. Probably some of these are familiar to folks that spend a lot of time in Pennsylvania. But the idea that we're in a situation where walking away from high hazard infrastructure and a lot of the fossil system that we have now really leaves really, really significant environmental liabilities for people, even beyond climate change, is something that I think folks are already quite familiar with. But the notion that having public control of a lot of these systems would bring those liabilities under the public umbrella, I think worries people sometimes just in terms of accepting those liabilities. And I guess the point that I'd like to make here is that those costs are already generally socialized. We see a lot of these kinds of things being walked away from. A statistic that I didn't bring here, but is the subject of a really, I think, neat paper by Josh Macy and Jackson Salavera, basically shows that bankruptcies from coal uh, companies have really, really resulted in quite a bit of shedding of pension liabilities and also remediation liabilities. Kind of demonstrates this point that eventually the public takes the burden here. And so one of the points about what public support might look like that really points to the notion that maybe the public has a hand in operating these systems for the purpose of decline is really trying to say, like, there's a point to potentially having the public accept some of the benefits as well as some of these burdens that are already socialized. This is just a quote and a picture from some interview work that I did in North Dakota a few years ago, but basically just illustrating this point that people do recognize that historically there's quite a bit of activity where companies just walk away from things, and that becomes really, really challenging in terms of who actually manages the liabilities afterwards. So these two examples, somebody talking about just abandoned buildings, people just handing the keys back to the bank and walking away. And another example talking about the fact that if you're not receiving royalty checks anymore, then suddenly a lot of the things that you maybe were willing to put up with, so in this case, nausea and nosebleeds for this person's family, those are a lot less tolerable when the money goes away. And so thinking again about, like, where is there potentially support for really managing the decline of this rather than just walking away from some pretty severe problems. I think we have a lot of history of what happens when we do allow things to kind of decline chaotically. So a couple more points, and then I will give you my example of where a potential demonstration project might come in. I think one of the other really, really interesting and important points to keep in mind when we think about the energy transition in the United States is that because we're bringing a lot of currently fossil-based energy uses into the electricity system with the goal of then being able to deploy cleaner energy resources that we turn into electricity at this point, we're actually talking about a much, much larger electricity grid than the one that we have right now. So this is kind of an agglomeration of outcomes from the EMF 37 Net Zero America modeling effort that happened a couple of years ago, basically suggesting that an electricity system that facilitates net zero in the United States would probably be somewhere between 5 and 8-ish terawatts compared to roughly 1 terawatt that we have now. So transitioning from the system that we have now to a future system isn't really about one-to-one replacement of the electricity system, because we're also bringing transportation into the electricity system. We're also bringing heating into the electricity system, and we're moving to resources that are less dense than the ones that we currently use. We may be looking at an electricity system that's 5 to 8 plus times the size of the one that we have now. This doesn't really include a lot of the impacts of like AI build out even. So pretty tightly focused on sort of optimal energy deployment for decarbonization. But I think the point here is you really are in an environment that looks very, very different from what we've seen before. And so the case for a lot more centralized coordination of this process of basically retiring a whole lot of stuff and then building a whole lot of stuff is, I think, quite a bit stronger than it has been when we've been talking about, reducing emissions by 10 or 15% at a time. So all of this kind of leads up to my thesis here that centralized coordination is necessary to really enact a successful transition here that leads us to decarbonization and hopefully also manages to preserve a lot of the very critical services that we have for people in an ideal world, also one that really structurally improves people's lives and makes it so that we don't have, neighbors that really can't pay their heating bills and things like this anymore. But that centralized coordination is not sufficient for good outcomes. So I talk a lot about the idea that having a federal government that's actually able to say this is the kind of production profile that we would like from these resources, and we're going to plan on these ones closing by this date, these other ones coming online by this date, and making sure that those are all coordinated. That really gives you a lot of opportunities to move forward in a way that's predictable, allows people to think closely about what that means for our communities and things like this. But the obvious question that I get a lot is obviously, well, if somebody doesn't actually want to do this for a managed decline purpose, you're not going to see decline. That's true. I think my argument is without some coordination, we're not going to get there at all. Some centralized coordination is probably has a pathway to actually succeeding, but it's certainly not sufficient. There is a normative underlying goal here where we actually have to decide that we're going to try to get to net zero before we're going to be able to do this. But I think the more that I look at these infrastructure systems, the clearer it is that the sort of historical policy theory of change that we've seen in the US, which is basically voluntary action driven by subsidies for um, movement within a market that exists that's really designed around a very specific fossil-based system is not actually, I don't think, capable of getting us to net zero. So looking at what these coordination functions might be and how we really think about the kinds of controls that would allow that to produce good public outcomes is, I think, a really important area to think about. So that might look like nationalization of a lot of these infrastructures for managed decline. It might look like state ownership or city ownership. There are a lot of different potential models, but without somebody that's actually able to make the decision of what closes and what opens, you probably don't really get there. Just as an example of this, I think one of the governance points that I've made recently, and this is work with Shuchi Chalati, who is now working on geoengineering and sort of deliberation around what that might look like. Um, our point was essentially that when we think about something like carbon dioxide removal, a profit driven marketplace, which is essentially what we have right now, is going to tend to produce the most profitable kinds of interventions with carbon dioxide removal, but not the ones that are most important for climate. And this is kind of a decontextualized graph in a lot of ways. But the point that this is basically making is that in a profit oriented market, you're going to end up with the people that have the highest ability to pay for carbon dioxide removal using carbon dioxide removal. Because CDR is actually a pretty limited resource, just because it's so energy intensive or land intensive, depending on the processes that you're using, that could lead you to a situation where you're doing a lot of compensatory CDR to offset ongoing fossil emissions, and then using up your capacity to do that on things that maybe could have been mitigated, but not leaving yourself a lot of space to use CDR for the things that are unable to pay a market price, but are actually pretty important for climate. So, for example, trying to offset ongoing greenhouse gas emissions associated with agriculture in very poor countries, you're never really going to see there be an opportunity for those emitters to pay for something at the prices that we see for carbon dioxide removal. Whereas sort of offsetting flights and things like that, where you have quite a lot of money in the system and profitability in the system, probably does allow you to pay for that CDR. But again, because this is a limited resource, that actually ends up being a bit zero sum, and you're not necessarily able to reach your targets. And I think the other piece about this figure that I'll just highlight really quickly is that there tends to be a bit of a public assumption that if we need some amount of CDR in order to reach net zero, any CDR deployment will actually fulfill that. The point that we're making here is that those black bars above the market price are actually adding to the total amount of CDR that you need to meet climate goals, not contributing to the overall volume that you need. So if you needed, 2 or 3 gigatons of carbon dioxide removal in order to meet some of the residual emissions targets that we see internationally, and then you start also using CDR to offset potentially mitigatable emissions, you're actually increasing the total amount of CDR that you need and therefore not necessarily reaching your goals. But this, I think, is an example of where there really is an opportunity to think very carefully about governance models and maybe moving away from kind of a profit-based per ton model to something that's a lot more centrally coordinated and kind of uses a lot of public values and public input into which kinds of things actually are what we're going to choose to use this limited resource of carbon dioxide removal to do. So happy to talk about that in the Q&A. But I think it's an important model for thinking about what governance could look like. with that, I think the maybe more concrete example that I wanted to talk about today from kind of a public support and public demonstration could be really focuses on some coal. And yeah, I see the question in the chat, and I will take that in just a second. I love it. But one example where we might see a governance demonstration coming from something like the federal government, and maybe even being modeled off of some of the way that we seek technology demonstrations moving forward in the past, potentially could focus on wind down of coal reserves in Wyoming. And I'll explain why this is such an interesting case potentially. So a lot of this is coming from a paper that I just published with Mijin Cha in Environmental Research Energy a couple months ago. But just to set the stage a little bit, this is a chart that shows coal production in the United States. The dark black line on top is total. The underlying one, the dashes, the small dashes that kind of go from zero and then take off in 1970 and then start declining again around 2008 is west of the Mississippi River. So primarily the Powder River Basin in Wyoming. And then the larger dashes are east of the Mississippi River. So largely Appalachia, Illinois Basin, those kinds of things. But I think what you can see here is that we have this massive ascent of Western coal. So Wyoming coal from 1970 to 2008 or so, largely actually driven by the Clean Air Act because that coal is low sulfur. And then since 2008, we've seen about a 50% decline in production in that area. The other context here potentially is that this is right now, I think the number is a little bit in flux because a couple of them have retired, but sort of 19-ish mines compared to several thousand in the east. But these are very, very large mines in northeastern Wyoming that produce about half of American coal and have really seen a very precipitous decline. The biggest among them is about 8 miles across, just to give you a little bit of a sense of scale. And so these are mines that are enormous, are unlikely to continue to be able to provide coal at small volumes. So they have a minimum scale that's kind of important. And then critically, they're actually on federal lands. This coal is federally owned and then leased out to companies. And most of those companies, I think all of those companies have gone bankrupt at least once since 2008, and many are kind of talking about exiting the basin. So the argument that Mijin and I make here is essentially that this is a really good opportunity to show whether we could actually, as a government, take over some infrastructure and really run it for eventual retirement in a way that improves outcomes because of a much more planned transition. What we see here right now is an extraordinarily unplanned transition so far. It's resulted in many, many layoffs, massive economic upheaval in the area, and real uncertainty for both buyers and the people that are running the mines. And so our argument is basically for the rest of it, this is a really good example of saying, well, maybe this is a place where you could have a much more centralized coordination role and essentially take over those resources and then think about what the timescale would be for eventual closure and remediation. The other kind of interesting point here, I think, is that we're in a situation right now where some of the mines have been closing because power plants are closing. So coal-fired power plants in the United States are actually very old. Most of them are beyond kind of their design life already, and we haven't built a new big power plant that uses coal since about 2012. But because those are so old and because they've been reacting to some regulatory environments, we've seen a pretty large decline in their demand for coal, which has resulted again in some pretty serious upheavals for the Powder River Basin on the supply side. What we haven't seen yet, but going back to the point I was making earlier about sort of predictable outcomes, is these very large mines closing and then therefore kind of forcing power plants downstream to close when they're no longer able to receive fuel. People may know it's not actually that straightforward for a coal-fired power plant to start using coal from a completely different basin with a really different profile. And so we're not quite there yet, but I suspect we are about to be in a situation where some of those plants are starting to be threatened by the closure of the mines. That is another real challenge of a lack of coordination. Having a system where you're actually able to say, this is the number of power plants that we have left. This is how long they're going to be operating. And so this is how much coal we need, really gives you an opportunity to plan for a sort of several year wind down that makes this a lot easier to manage. And then because coal is a solid fuel, also gives you the opportunity to sort of mine that and stockpile it, still operating at the scale that the mines need, while ensuring that the plants on the other end have what they need without really needing to have those mines still be open. So there's a lot of reasons why this kind of presents an interesting example for trying to prove whether we can do this. Because yeah, like I said, I think My feeling here is that centralized coordination is necessary. There are a lot of ways that it could go wrong, but especially in a situation where you're trying to build trust in the notion that this kind of governance could work. Having a couple of examples that are basically keystone studies that show that maybe we could actually operate these for managed decline, demonstrating that governance through a couple of big projects, I think is pretty important for showing that it can be done. This is also from that same paper, but essentially showing that demand is pretty spotty from a couple of different compliance scenarios as we've seen sort of historical efforts to regulate coal. And I think the main thing that I'll call your attention to is that business as usual coal demand from some of these mines is actually probably lower than it is under what is currently in place but may go away, a 111D compliance scenario, which is essentially a greenhouse gas regulatory structure for power plants. But because some of them are actually promoting carbon capture, that may increase coal production from or coal demand from several of these mines. That becomes really, really difficult to plan around because we're not super sure how successful those carbon capture decisions might be. It's somewhere where you have a lot of different decision makers that are operating without coordination in a way that could be actually really, really challenging. But the bad scenario here basically is that a whole bunch of power plants invest in very, very expensive carbon capture plans, sort of $1 billion per plant scale kinds of projects. And then because the mines did not know to be ready for that, potentially they're unable to move forward because there's no coal. Or similarly, that a mine really gears up for producing a huge amount of coal because of this expectation about carbon capture that never materializes. There are a lot of ways that we could see kind of a misallocation of massive, massive amounts of capital here. That all leaves aside the question of whether carbon capture is actually a good idea, given a lot of the other resources that we have in the electricity sector. But I think the point is that a lack of coordination between the suppliers and the demanders here could actually lead to some pretty significant and very costly outcomes. And then the last thing that I'll point out on this one in thinking about this as a potential governance demonstration is that there is a huge amount of volatility actually in the way that these systems could operate. So the way that I'm characterizing this is basically that the minimum viable scale where below some threshold, facilities will start to be inoperable, essentially. And if you're familiar with hydropower, maybe the analog here is basically when the water falls below the intake, even if your reservoir is still 60 or 70% full, you're not going to be producing anything in a very nonlinear fashion. So for most big networked fossil infrastructure systems, there's not really a way to linearly decline how much you're actually using these systems. There comes a point where below some certain size, you lose economies of scale very rapidly and probably see pretty chaotic shutdown. What we see for the Powder River Basin is that for a lot of these big mines, the number of power plant generators that actually would need to close in order to threaten the entire mine's ongoing ability to run. And again, kind of recognizing that the scale of these things is really, really enormous. So just like the individual pieces of equipment that they're running have kind of minimum scales that they can use. But it's for a lot of these mines, actually much, much less than 25% of those generators would need to close in 1 year to basically cause the mine to shut down. So Black Thunder and North Antelope Rochelle, both really, really large mines, maybe the biggest mines in the world, but both have been capable of producing 100 million tons of coal per year. At its peak, the US produced 1 billion tons of coal. So each of these mines was basically producing 10% of, at the time, the biggest coal producer in the world's coal, which is sort of wild to think about. But in both of those cases, it's sort of 12 to 15% of the generators they supply that would need to close that would basically cause such a massive profit loss in a year that the mines might go out of business. So this is not to say that we're not talking about a pretty rapid closure of fossil assets, but to say that if that happens in an unplanned way, you can actually end up in a very chaotic and very painful situation. And yeah, if you look at this sort of generally, it doesn't take that many generator closures to threaten these mines. And this is just an example from the Powder River Basin. You can make a very similar case for refineries and natural gas pipelines and gas stations and all these kinds of things. But the point of losing economies of scale, causing really, really rapid nonlinear decline is a really important reason, again, I think, to support some research into how we might be able to do better governance that allows for a bit more of a managed decline. Yeah, Let me actually take Antonia's question before I wrap up because I think this is a really important one. So, related to comments about poor assumptions and implications for reliability and safety, could you talk some about how extreme weather and variability shape planning and coordination in this transitional period? Yeah, absolutely. And I think that one of the arguments that I would make for why I'd like to see public control of a lot of these systems is that you see a lot more agility when the whole system is kind of collectively managed. A central coordinator is more able, I think, to say, we're going to keep one of these plants that we had intended to close online for a couple of more years. We're still going to close it, but we need to keep it online because we're seeing this discontinuity in our reliability or something along those lines. But just that ability to sort of actually change what your plan is on a pretty rapid timescale without completely interfering with a market structure or something like that, or really creating a lot of very challenging private incentive problems where you need to be basically asking people to do this. I think you end up in a situation where a lot of that coordination, because it's much harder, is actually a good argument for doing this at a more centralized level. I think what I get really worried about with the extreme weather kinds of things is that you have so many different actors making basically voluntary decisions about how they're going to be planning for a lot of these types of futures, whether that's because of climate action or not, that you end up with really patchy planning that can be kind of devastatingly dangerous if it's not done very well. So again, this is not to say that if you had centralized coordination, then every decision would certainly be much better, but it would allow you to have a lot more shared information about what's available, what you're planning for, what system is actually going forward, et cetera. And I'm not making an argument that that would be more financially efficient from just kind of a cost of service perspective. I think in the long term it probably would be, but this is a situation where we do probably need to overpay for a little while in order to not see really significant disasters. And internalizing those costs of those risks is, I think, another pretty good argument for pulling this into a more public control situation because the negative outcomes are going to be socialized already. But yeah, the climate change is making this all more complicated element, and the sort of patchy deployment of end user equipment is making this all more complicated, is a lot of what I spend time thinking about and a lot of what worries me here. So yeah, thank you for the question. All right, so last couple minutes, just to kind of make a point that's a little bit more from my more sociological work, is that people are a lot more supportive of transitions when it's clear that there's a plan. I think this is something that I've been kind of surprised to see. I spend a lot of time in fossil fuel dependent communities trying to basically get a sense of what value systems are at play and how that looks when we were thinking about trying to plan a better transition. But one of the things that comes up quite a bit is basically this argument that closing a whole bunch of industry is not necessarily going to be super well received by people in general. But when that's happening for reasons that don't seem to be providing any sort of benefit, there's a lot more suspicion of that. When there are situations where there's much clearer explanation of, here are the risks that are coming, here are the kinds of things we're going to do to mitigate those risks, and here's like a very, very clear explanation of what we're trying to do here, there's a lot more support. So this is an example from actually a listening session by the Environmental Protection Agency on the Clean Power Plan, which is Obama era policy that was subject to a repeal during the last Trump administration. But basically, this is an extraordinarily coal dependent region. So same region that I was just talking about in the Powder River Basin up in Wyoming. But looking at how people were responding to the call to repeal this plan, there was a lot of really, really interesting rhetoric here, actually. So on the left, somebody talking about the plan as an example of how misguided we are in that we are willing to sacrifice for essentially nothing. If we're going to inflict that kind of sacrifice, we should be considering investments that actually benefit humankind. So the point that I think was coming out a lot in those kinds of comments was basically like, if you are just going to destroy the industry that supports our community, what we're seeing from the proposal around the Clean Power Plan is that the benefits aren't significant enough. If you can show us how this is actually going to work, and if you can show that there's actually going to be benefits, like, I'm listening, but it doesn't seem like this one has that. Then on the right side, something very similar, talking basically about people really recognizing a lot of suffering in coal communities historically. And this is a kind of an ongoing cultural image and one that's held pretty deeply in some of these regions. But this person says the Clean Power Plan needs to not be repealed, but needs to be expanded to show respect and appreciation for the sacrifices that have been made. So this notion, I think, that people are supportive of things that they expect to be effective, but not supportive of things that they don't expect to be effective is a really interesting point because in this area, the general view, and even with these comments, was basically, we would like to see this repealed, but more because they thought that it wouldn't do anything than because they were fundamentally opposed to the idea of a transition here. And that's actually quite different from some of the rhetoric that I used to hear when I went out to Gillette like many years ago. So that transition has been interesting to watch. But this notion that actually being able to say, yes, this is the plan, this is what we're actually doing, this is how we're going to make sure that people are okay and supported through this, those are the kinds of governance demonstrations that I think are pretty necessary when we think about publicly supporting this overall transition and seeing what kinds of things we could do to expand some of these activities. So in general, I think looking at how the federal government or state governments or other bodies actually think about designing policy here, there's a lot of care needed to ensure that those policies actually align with people's needs. One of the things that I've been saying for a little while is that I actually think that something like universal healthcare in the United States is a basic prerequisite for successful climate action because there's so much concern in a lot of these fossil dependent communities about job loss leading to healthcare loss and then really significant problems for people's families. But stuff like that, where you actually do see opportunities in a more coordinated transition to really spot some of the issues and try to mitigate them before they happen. There's a lot of potential there that I think kind of exceeds what we've seen in the past of basically just seeing stuff kind of close without any notice and without any coordination, leading to really, really severe economic and cultural harm in a lot of these places, and environmental harm for that matter. So the notion that having a centralized coordinating function that can actually ensure that this transitioning is happening, but also actually having to prove to people that you can do that in a way that's going to really address a lot of the issues that people have, I think points us to kind of a new regime where it's not really so much about just demonstrating whether a technology works. It's about demonstrating that a pattern of deployment and a pattern of planning might work. And so this notion of governance demonstrations, I think, is a kind of an interesting thing to be poking at, and we're going to keep doing some work on that. So I'll stop there and I'll stop screen sharing. But if people have questions, like feel free to come. Well, I'll defer to Chiara about how you want to manage Q&A. But thank you so much for spending part of your afternoon with me.
Thank you, Emily. That was great. Let's see, Michael.
Yes.
Hi. Yes, please go ahead.
Well, thanks. Yeah, that was quite a. I really like. The only problem was your slides were too wordy. It was hard to read, but no, I really like that. So this notion of transition, I've been reading that it's the wrong word, because we're not going to get off fossil fuels anytime soon. Like I'm a forester, so we use more wood than ever before. There's talk about we're still using a lot of coal, even more than, in the past century. And, you say we reduced it 50%. So but we're still using all these resources. And so, like we still need, you talked about electricity, but we know we need coal for making steel and things like that. So I'm just wondering if transition, my first question is like, is transition really the right word? I mean, I know where you're trying to get to, but and then I hear like electric cars, like 60% of electric cars still run on coal, right? To make the electricity for them. Things like that just makes me wonder if we're really transitioning, because these fossil fuels, we're actually using more than we did before, although in percentage wise, it's becoming less, right? Because of renewables.
Yeah, thank you for that question. And I think that I will reiterate that I actually am talking about transition and phase out. And I think that one of the reasons why this governance conversation is so important is exactly what you're talking about. The stuff that we've tried historically has not actually really resulted in a real transition. If we are actually going to reach zero greenhouse gas emissions rather than, 20% cuts, 50% cuts, those kinds of things, we actually do need to be talking about a transition, which we've never succeeded at before. And so these new models of governance that are really intended to enact phase out, I think, are part of why we need to focus on this kind of thing, because what we're doing right now is unlikely, if not basically impossibly going to actually get us to a full transition. So yeah, and I think like there are a lot of really complicated pieces of this transition that do probably mean some ongoing investment in fossil systems for safety reasons in the near term, but keeping a general focus on doing that for very short-term reasons just to kind of bridge so that they can be phased out, I think is the focus of really thinking about what kinds of models and what kinds of projects we could do to demonstrate that we're capable of these things. But yeah, that remains in question for sure. But yeah, I'm an advocate for actual transition, and I really appreciate the question.
Good. But no one's asking questions.
I wonder.
What do you think of
Oh.
what do you think of the wood energy side, like BECCS and things like that? Does that have a role in this transition?
I'm suspicious of BECCS. I think the carbon accounting is pretty challenging, and I think that a lot of the way that it gets talked about as a deployable technology is pretty challenging. Um, I think it's worth doing a couple of tech demonstrations to see if it actually can deliver on the kinds of things that people are asking it to. But I think basically we sometimes talk a little bit too much about forests as being able to actually provide a carbon sink that is additive to what it's been before, without talking about the fact that we've lost so much carbon sink potential that we actually have a lot of forest that needs to be put back in order to kind of to mitigate the carbon sink that's been lost before we can really start talking about that as a removal process. So I'm that's not my first choice of a thing that I would like to be seeing deployed. Maybe.
All right. And one last question is just like, are there countries or places where they've reached that, getting to that index where you had from 0 to 1 in terms of renewable, really transitioning?
Not yet. And I think that that's another reason why, at this point, I think that it's not really about technology demonstrations so much as about governance demonstrations. Like, we actually do need to do things that are different from what's happened before. There are a few examples, not for climate reasons, but there are a few examples of sort of managed decline of specific industries. So, particularly on the energy side, one of the examples that we look to a lot is basically when the European Union and its predecessors were forming, there was quite a lot of effort to make sure that countries were not sort of over subsidizing their own coal industries relative to others in a way that would be detrimental to the entire European project, basically. And so there was a lot of rationalization that had to happen there. Some countries did this better than others, but the kind of notion that some of those industries were being intentionally phased out, that's probably the best example on the energy side. There's a few other examples. So in the American context, something like the passenger rail consolidation also didn't go great, but it's an example of where we really started to see an industry sort of being intentionally shrunk. But yeah, like there are not a lot of great examples of people doing this on purpose. And I think that's, again, why having some role both for research and for trials of how this might work, we're really in a place where we need to do some more of that and prove that we can.
Thanks. I can keep going, but I'll let other people.
Yeah, I don't know if, oh, okay, Casey. I don't know if Nicholas had a question. Just wondering there. No, okay, good. Then Casey, please go ahead.
Hi, thanks, Emily. So when you talked about governance structures, you talked about the kinds of challenges that they need to be able to address, the kinds of capabilities that these structures need to have, but you didn't talk very much about what these structures actually look like. You listed a lot of options. Could you say more about, I don't know, I guess why you're so agnostic about those structures right now?
Yeah, and I'm not sure that I'm agnostic so much as I don't have the data to support some of my hypotheses quite yet. But no, it's a good point. It is a bit of a gap. I think just like personal hypothesis so far, it's my view that probably a federal ownership of the energy system, something that looks a lot like that in practice, might be state, might be federal, might be something else, but something that's a pretty centralized, pretty command and control approach at some level is actually going to be important if the goal actually is zero. Because I think what's different about this than a lot of other environmental processes that we've seen is that we're not trying to optimize some emissions and these kinds of things. We're actually trying to eliminate them, which means every single generator, every single vehicle, every single gas heater, that actually does give us a very, very clear roadmap of where we're going in a way that I think is a little bit different than saying, you know, what are the 80% of the cheapest emissions cuts that we could achieve or something along those lines. And I think the reason why I always talk, I think kind of skittishly maybe about necessary but not sufficient is that obviously centralized control can go in a very bad direction at times. One argument I think is that, you know, if you have a federal actor who is not interested in pursuing climate action, you're not going to get there regardless. And at least if it was publicly owned, those revenues would come back to the public rather than being completely privatized. But nonetheless, there are, I think, a lot of pitfalls in any way that we approach this. It just happens to be my feeling that basically federalizing a lot of this gives us the best shot at actually getting to zero. But that doesn't necessarily mean that it would certainly succeed. And I think that the challenge of something at a smaller scale is basically that we have such an interconnected set of these really networked infrastructures, and you do actually need somebody to operate them, even if there's not a company that's able to do that. I just don't see an actor other than the government who would be able to do that in the long term.
And could you just talk a little bit about the difference between that scale of governance that you envision and what would be required for a demonstration project?
Yeah, absolutely. So I think, and maybe it's also important to make this point because I don't think I said this. The United States is actually incredibly unusual in that we don't have national ownership of minerals in particular. So part of the reason why there aren't a lot of other examples of this kind of transition is that most countries aren't going from a system of private ownership to a system of public ownership. It's already publicly owned. But I think the point about the demonstration on the way to a fuller management schema is that, yeah, people don't really trust that the American government could do something like this. And the ability to actually move forward without having an answer to that question that, yeah, I think I got today. I get pretty much every time I talk about this of like, has this ever worked before? If there's an opportunity to show, yes, it did work and it worked pretty quickly and people were pretty happy with the outcome, that gives you, I think, a lot more runway to expanding that pretty quickly because there are going to be real challenges with this. Just the fact that we're dealing with an aging system that is also dealing with climate, is dealing with an aging workforce, all these kinds of things. We anticipate quite a lot of challenges with operating the fossil system. If that coincides with a sudden transition to public ownership, like the notion that people would blame this on the ownership change is pretty clear, I think. And so building up a little bit of trust with people to say, like, we see these things coming. Look, we tried it over here, and these are the things we predicted. This is what happened, and this is what we did. I think that smaller scale demonstration in particular sets of infrastructures probably needs to happen quickly, but does need to happen before you can go all out and have people actually be willing to forgive you a little bit when things are bumpy.
Thank you.
Yeah, I have a question that actually builds on the first question that Casey asked. I'm really curious about what you think, so how might a governance structure look like in electricity systems that have markets? And maybe I can add a little more to that. I mean, you know that a lot of my research is on markets, and about 2/3 of the consumers in the United States today are served by grid operators that run markets. And very, very recently, I reviewed with a colleague at RFF, we reviewed 11 electricity market designs that have been proposed to address different challenges of the clean energy transition. And one of those designs in particular is pretty much proposing that I mean, they're proposing a notional long-term planning exercise that would be run by the grid operator to pretty much identify the needs of resources for we're talking about generation capacity. So the grid operator would do the grid and capacity expansion planning for the entire system. And that would pretty much replace what is happening right now, where decisions on capacity expansion planning are made by the individual agents and operators in response to market incentives. So this proposal has, as you may as you may imagine, this proposal is encountering some pushback, and some say that it's absolutely not feasible. It's never going to happen. The RTOs are never, which are the grid operators, just in jargon, they're never going to do this kind of long-term planning exercise. So I'm curious, like, what could a governance structure look like in your more coordinated world? Do you think that this might be an example, or are you thinking of other examples in regions where markets are operating?
Yeah, I think it's a really good question. And I will say, like, I'm a little down on the idea of continuing to allow this be market-based, actually. And like, I know that's kind of it's one end of the spectrum of how people think about this. But I think particularly with energy stuff, like we intervene so heavily in these markets already that there are a lot of characteristics of a more coordinated system because we don't want to let the system fail, obviously. So I think you're right. Like there's a massive amount of pushback around the idea that this wouldn't be something that is purely responding to incentives, but precisely for this reason that right now you do have a lot of actors that are responding separately to incentives, that really hampers your ability to move forward. And so like again, I realize that I'm on one side of this conversation probably, but I would probably prefer to see this be something where an actor, whether that's the federal government or something like a state government, essentially says, okay, like all of the fossil system needs to be retired by X date. That means we need to deploy this much new renewable. And like maybe you have some market-based mechanism to determine what that mix of the renewable fuels looks like. But something that is a lot more command and control and regulatorily based is more what I'm envisioning here. I imagine there are ways you could do it that kind of transition from the market-based system that we have now a bit more fluidly. But I think any system where you have basically decisions being made on the basis of asymmetric information is going to really block progress in some of these if you do kind of allow for the continuity of fossil system operations.
Thank you. And now Nicholas does have a question.
Do we still have time, or are we at time already? I just want to make sure.
I think we have, and maybe Ava can tell us. We have until 5:10 or so, maybe. Is that right?
Yeah, we
Or-
can take another question.
Okay,
Oh, yeah,
let's.
I'll keep it brief. Yeah, thanks for a great talk. And sorry, I missed the very first part. So apologies if you had covered this, but I'm curious. I know a little bit more on the oil and gas side, but for coal, I'm curious how much royalties account for like local, like municipal and state budgets. And obviously like a big part of the transition is like how do you not just replace the energy system but also the financial resources that or had been supporting these communities, and do you see any differences or maybe better opportunities to do that with the command and control system versus kind of letting the markets let these industries slowly die out?
Yeah, and that's a great question. I think it depends on where you are. The thing about coal that is quite different from oil and gas is that a lot of it has declined so precipitously already that most of that transition has already happened chaotically and in sort of devastating ways for the communities that host it. So it's sort of an unfortunate reality that we've kind of missed the boat on the coal transition. Like the I think every time I update this slide for my class, I'm kind of shocked at how fast the number goes down. But at peak, I think the US had something like 200,000 coal miners. Now there's 40,000-ish, and maybe about 8,000 of those are actually who you would think about as being coal miners. A lot of the rest of them are things like accountants and mechanics and things like that. But the industry has essentially collapsed. Every single coal company in the US has gone bankrupt at least once in the last 15 years and has discharged massive amounts of like pensions and remediation bonds and things like that. So the royalties can be sort of significant, but because, like, contrary to oil and gas, you tend to see coal regions actually producing for a very long time in one place because you don't have the same kinds of decline curves that you have with individual wells and such. Like Kern County, obviously being kind of the more coal-like example in the oil industry, but there's a lot of systems where they're very, very place-based in ways that are not that rotatable. You also, contrary to oil and gas, don't really see a lot of private ownership of coal on an individual level. So you might see a company owning a lot of coal minerals, but you don't see like a person owning a lot of it. And so the kinds of people that have power around coal are quite different than you see with oil and gas. But yeah, the royalties can be meaningful. They're actually much smaller than I think we expected. I did a project with a couple of colleagues also at RFF a few years ago where we were trying to kind of quantify that. And the amount of money that we're really talking about here is pretty low. Severance taxes are quite small for coal, and like Yeah, without getting too deep into it, basically Wyoming has much smaller severance taxes than Montana. Montana actually has more of that coal basin that I was talking about, but they essentially have produced almost nothing out of it because the royalty difference is so significant. But there's sort of been an intentional suppression of royalties in a lot of the industry that means that, you know, you can make the argument that it would affect places, it would, but at the same time, sort of a more centralized view of this that actually does acknowledge that this is going to be a pretty expensive thing to do. When you talk about potentially buying out all of those royalties and maybe even buying out all of those jobs, you're talking billions of dollars, not like tens or hundreds of billions of dollars here. So I think if you're willing to just pay for it, it's not actually that large. Obviously, like there's a lot of questions about dignity of work, community continuity, and those kinds of things. But from an actual revenue replacement perspective, it's not that much money.
Can I ask one more?
Yes, yes, please. You started and you'll be the last one. Yes.
No, the carbon CDR. So what technologies do you like? I mean, you know, that actually are carbon negative.
Yeah, that's a great question. I care a lot more about what it's being used for than what the actual technology is. I have probably a bias toward geologic storage for things that I think are likely to be more effective, but I think CDR that is being deployed as an offset for an ongoing emission that could have been mitigated is just an incredibly inappropriate use of it, regardless of the technology that goes in. CDR that actually does result in removal of CO2 from the atmosphere. Yeah, I think there are a number of pathways that you can go to. I quibble a little bit with the biological storage people about whether that's mitigation or removal, but I think the point that I keep coming back to is like, what are you using it for? Because if you're using it for things that you actually need CDR for, then that's a very different scenario than if you're using CDR instead of mitigation.
Yeah, thanks.
Thank you all so much.
Thank you very much, Emily. I think your talk was great and the discussion was lively. I'd be happy to follow up with you on the market part. I'll send you the review and
that'd be great.
I want to talk more to you about it because I'd be curious to hear what your perspective is. But with that, I think we can just, Eva, I think, do you have any announcements or like, no?
Nope, not much. We do have one more seminar planned, and that will be David Himes, and he will be next week.
Yeah.
So, yep.
All right. Thank you very much. Thank you all for attending, and thanks, Emily, again. Bye. See you.
Thank you.
Bye-bye.
Bye.
Yeah.